The following is a selected video from videomathteacher.com, where you can explore over 10,000 videos, print out practice worksheets, find proofs and discussions on many math topics, and explore related videos. Try videomathteacher.com today. Let's integrate the following integral. We're given the integral of 1 over the square root of 9 minus 4x squared dx. To integrate this, we'll use a trigonometric substitution. So we'll begin by recognizing which trigonometric substitution to use. And that would be, since we have two quantities, 9 and 4x squared, that appear to be something squared, let's determine what is being squared to produce 9 and 4x squared. What squared is 9 becomes 3, and what squared to produce 4x squared would be 2x. If we consider 3 as a constant, say a, this would match a squared minus, and if we considered 2x as a variable u, this becomes a squared minus u squared. This suggests that we should use the trigonometric substitution of u equaling a sine theta. So in our problem, u was 2x, so we'll write down 2x equals a, which is 3, sine theta. So this will become our substitution in our problem. Let's now manipulate this substitution into the denominator, as well as differentiate our substitution to replace dx in terms of d theta. So let's first manipulate our substitution 2x equals 3 sine theta into the denominator. To do this, we'll first write the substitution again, and we'll square both sides. So squaring both sides of the substitution, we get 2x being squared becomes 4x squared equals squaring 3 sine theta squared becomes 3 squared is 9 sine squared theta. In our denominator, we have 9 minus 4x squared, so we'll now subtract 9 minus from both sides of this substitution. So we'll have 9 minus on both sides. 9 minus 4x squared is on the left side, and 9 minus 9 sine squared theta is on the right. But the right side can be simplified further. We'll factor out a 9, so we get 9 times 1 is 9, minus 9 times sine squared theta is 9 sine squared theta. And 1 minus sine squared theta is a trigonometric identity for cosine squared. So our right side becomes 9 times cosine squared theta. So far, 9 minus 4x squared becomes 9 cosine squared theta. In our problem, we had a square root. So next, let's square root both sides of the substitution. So the left side will become the entire denominator, square root of 9 minus 4x squared, and the right side will be the square root of 9 is 3, and the square root of cosine squared is cosine theta. That means that our integral will become the integral of 1 over, instead of writing square root of 9 minus 4x squared, we'll write this as square root of 9 minus 4x squared is 3 cosine theta. Next, we need to also manipulate dx into an expression with d theta. To do that, we'll differentiate our original substitution of 2x equals 3 sine theta. So differentiating the left side, we'll get 2 times dx, and on the right side, the derivative of 3 sine theta becomes 3 cosine theta d theta. Since we have dx, not 2dx, we'll also choose to divide through by 2 for the substitution. So dx is equal to 3 halves cosine theta d theta. So dx in our problem will become times 3 halves cosine theta d theta. Let's write this substitution again below and simplify. So copying and pasting, we get that this becomes so far this expression. So to simplify, all the constants, such as 1 over 3 and 3 over 2, are numbers that can be written outside the integral. So this will become 1 over 3 times 3 over 2 times the integral of 1 over cosine theta times cosine theta d theta. We see we can simplify. Since in the fractions 3 cancels into 3 once, we're left with a fraction of 1/2. And we see also that the cosine thetas will cancel, leaving the integral of 1 d theta. This is a known integral that we can integrate. The derivative of what would be 1 in terms of thetas, and we would see that this would be a single theta, since derivative of theta would be 1. Of course, we had the 1/2 in front. This could be our answer. However, our original problem was in terms of x's, not thetas. So we need to change our result theta back in terms of x's. To do this, we'll use our original substitution again, that 2x was equal to 3 sine theta, and solve for theta and replace that in our result. To solve this for theta, we'll first divide both sides by 3 to get that 2x over 3 is equal to sine theta. And by applying an arc sine to both sides, the sign on the right will move to the left side as an arc sine. So arc sine of 2x over 3 would equal what theta is. So in our final result of our integral, we have 1/2 theta, and replacing theta with our arc sine of 2x over 3, we get the result of 1/2 times arc sine of 2x over 3. Since we're integrating without limits, we would also pick up a plus c, plus constant. So this becomes the answer to our integral. In other words, our original integral, the integral of 1 over the square root of 9 minus 4x squared dx, becomes the final answer of 1/2 arc sine of 2x over 3 plus c.